Hi, in this video, we are going to see how to find the derivative of an integral using second fundamental theorem of calculus. Let us consider the integral a to b f of t dt. Okay, I want to find the derivative of this integral using the second fundamental theorem of calculus. I assume this integral is equal to g of x. Okay, now my aim is to find g prime of x, that is the derivative of g of x, and also that is the derivative of this integral. Okay, so using second fundamental theorem of calculus, we have a formula to find derivative of this g of x. That is g prime of x is equal to, you have to take the first derivative of this upper limit of the integral, that is b prime times f of b. In this function, you have to replace this t by the upper limit b. Now take negative sign, take the derivative of the lower limit, which is a prime. Now in this function, you have to take the lower limit a, that is f of a. So this is a formula we have to find the derivative of an integral using the second fundamental theorem of calculus. So here we have three derivatives, g prime of x, b prime, a prime. Since g of x is a function of x, all the three derivatives in this formula have to be done with respect to the variable x. Okay, now let's look at an example. Consider the function g of x is equal to integral -2 to x t square -2t times dt. Here, instead of f of t, we have t square -2t. So f of t is equal to t square -2t. Okay, now g prime of x is equal to the first derivative of the upper limit, which is x prime times f of the upper limit, which is x negative. This derivative of the lower limit, which is -2 prime, f of the lower limit -2. Okay, so here I've already told you, so g of x is a function of x. All the three derivatives we have here have to be done with respect to x. When you find derivative of x with respect to x, it will be 1. And to get f of x, you have to replace this t by x. So here also we have to replace t by x. Then we'll be getting x square -2x for f of x. Okay, -2 is a constant, so the derivative of a constant is always 0. 0 multiplied by anything is 0. So 1 times x square is x square, 1 times -2x is -2x. Finally, we get x square -2x. So the derivative of gx, that is g prime of x, is equal to x square -2x. Let's look at another example. Consider the function g of x is equal to integral 1 to x square root of t times cosecant t dt. And we have square root of t times cosecant t for f of t. Okay, so g prime of x is equal to the derivative of the upper limit times f of the upper limit negative, the derivative of the lower limit, which is 1 prime, f of the lower limit 1. Okay, so the derivative of x with respect to x is just 1. To get f of x, you have to replace t by x in this function. So we get square root of x times cosecant x negative. The derivative of a constant, the derivative of the constant 1 is 0. 0 times anything is 0. So we get 1 times square root of x times cosecant x will be square root of x times cosecant x. So g prime of x is equal to square root of x times cosecant x. Okay, now let's look at another example. G of x is equal to integral x to x plus 2 4t positive 1 times dt. So f of t is equal to 4t positive 1, and g prime of x is equal to the derivative of the upper limit, which is x positive 2 prime, times f of the upper limit, which is f of x plus 2 negative the derivative of the lower limit, which is x prime, and f of lower limit, which is f of x. Okay, now we can calculate f of x plus 2. So to get f of x plus 2, you have to replace this t and this t by x plus 2. So f of x plus 2 is equal to 4 times x plus 2 plus 1. So 4 times x is 4x. I distribute this 4 to x and positive 2, and 4 times 2 is 8, positive 1. We get 4x, positive 9. Okay, now, okay, the derivative of this x plus 2 is just 1, because the derivative of x with respect to is 1. The derivative of this constant is 0, 1 times, and f of x plus 2 is 4x positive 9. Negative. The derivative of this x with respect to x is just 1. And for f of x, you have to replace this t by x. We get 4x positive 1. So if you distribute this 1 to 4x and positive 9, it will still be 4x positive 9. And you have to distribute this negative 1 to 4x and negative 1 to 1. So when you distribute the negative 1 to 4x, it will be negative 4x. Negative 1 to 1, it will be negative 1. So positive 4x and negative 4x will cancel out. And when you combine positive 9 and negative 1, it will be positive 8. So g prime of x is equal to positive 8. Let's look at another example. Consider the function g of x is equal to integral negative x to positive x t cube times dt. F of t is equal to t cube in this case. Now g prime of x is equal to the derivative of the upper limit, which is x prime, times f of the same upper limit x negative the derivative of the lower limit f of the same lower limit negative x. So the derivative of this x with respect to x is just 1. And to get f of x, you have to replace this t by x. So f of x is equal to x cube. Negative. The derivative of this negative x is just negative 1. And to get f of negative x, you replace this t by negative x. Then we get f of negative x is equal to negative x the whole cube, which is equal to negative x cube. So f of negative x is equal to negative x cube. So here you can replace this f of negative x by negative x cube. So 1 times x cube is x cube. Negative times negative becomes positive. 1 times negative x cube. Now x cube. Positive times negative will be negative. 1 times x cube is just x cube. Finally, it results 0. So g prime of x is equal to 0. Let's look at another example. Consider the function g of x is equal to integral 0 to sine x square root of t dt. In this case, f of t is equal to square root of t. Okay, then g prime of x is equal to the derivative of sine x times f of sine x negative the derivative of 0 times f of 0. Okay, here the derivative of sine x is cosine x. And to get f of sine x, in this function, you have to replace this t by sine x. Then we get f of sine x is equal to, on the right side also the t has to be replaced by sine x, and we get square root of sine x. So f of sine x is equal to square root of sine x negative 0. The derivative of 0 is 0. 0 times anything is 0. So finally, we get cosine x times square root of sine x. So g prime of x is equal to cosine x times square root of sine x. Okay, now let's look at another example. G of x is equal to 2 to x square 1 over t to the third power dt. In this case, f of t is equal to 1 over t2. Okay, now g prime of x is equal to x square prime times f of x square negative 2 prime f of 2. Okay, the derivative of this x square with respect to x is just 2x. And already we know f of t is equal to 1 over t cube. And for f of, we have to get the stuff which is equal to f of x square. So for that, you have to replace this t by x square. On the right side also, we have to replace the t by x square. So if you replace this t by x square, you'll be getting x square. Already we have the exponent 340, so the same exponent 3 is taken for x square. So 1 over x to the power of, we have to multiply these two exponents, so we get 1 over x to the 6th power. So 1 over x to the 6th power negative. The derivative of a constant 2 is 0, 0 times anything is 0. And now we have 2x over x to the 6th power. When you simplify this one, we'll be getting 2 over x to the 5th power. So g prime of x is equal to 2 over x to the 5th power. I think this video helps you a lot to understand how to find derivative of an integral using the second fundamental theorem of calculus. Thank you.